From the kinetic theory of gases, a gas is composed of a large number of molecules that are very small relative to the distance between molecules. The molecules of a gas are in constant, random motion and frequently collide with each other and with the walls of any container. The molecules possess the physical properties of mass, momentum, and energy. The momentum of a single molecule is the product of its mass and velocity, while the kinetic energy is 1/2 the mass times the square of the velocity. As the gas molecules collide with the walls of a container, as shown on the left of the figure, the molecules impart momentum to the walls, producing a force perpendicular to the wall. The sum of the forces of all the molecules striking the wall divided by the area of the wall is defined to be the pressure. The pressure of a gas is then a measure of the average linear momentum of the moving molecules of a gas. The pressure acts perpendicular, normal, to the wall. The tangential, shear, component of the force is related to the viscosity of the gas. Scalar quantity. Let us look at a static gas, one that does not appear to move or flow. While the gas as a whole does not appear to move, the individual molecules of the gas, which we cannot see, are in constant random motion. Because we are dealing with a nearly infinite number of molecules and because the motion of the individual molecules is random in every direction, we do not detect any motion. If we enclose the gas within a container, we detect a pressure in the gas from the molecules colliding with the walls of our container. We can put the walls of our container anywhere inside the gas, and the force per area, the pressure, is the same. We can shrink the size of our container down to an infinitely small point, and the pressure has a single value at that point. Therefore, pressure is a scalar quantity, not a vector quantity. It has a magnitude but no direction associated with it. Pressure acts in all directions at a point inside a gas. At the surface of a gas, the pressure force acts perpendicular to the surface.
Theories or a pressurized system next to an unpressurized system without a barrier makes no sense. There is supposedly no physical barrier between our atmosphere and the supposed infinite vacuum of space above or around it. Spaceships and rockets fly in and out of our atmosphere all the time, right? So how is it that our tiny little atmosphere doesn't just get sucked out and everything else equalizes? Because in the real world, if you have a vacuum in one place and some kind of gas in another place, and you remove the barrier, that's precisely what happens. It equalizes. Gas next to a vacuum without a barrier makes no sense. And there's a chance I know what you're going to say, and I will address the theory of gravity soon enough.
Hello my friends. This is a Hebrew map of the earth. In biblical cosmology, the firmament is the vast solid dome created by God during the Genesis creation to separate the waters above from the waters below. In English, the word firmament is recorded as early as 1250. In the books of Genesis and Exodus. It later appeared in the King James Bible. The same word is found in French and German Bible translations, all from Latin firmamentum, a firm object, used in the Vulgate, 4th century. This in turn is a calque of the Greek word stereoma, also meaning a solid or firm structure, which appears in the Septuagint. The Greek translation made by Jewish scholars around 200 BCE. These words all translate the biblical Hebrew word rakia, used for example in Genesis chapter 1.6, where it is contrasted with shamayim, translated as heavens, in Genesis chapter 1.1. Rakia derives from the root arku, meaning to beat or spread out thinly. That's all. Please comment and subscribe for the best maps. Goodbye.